So this is a Math Counts 2014 target round. We're going to do the last four problems, starting with the number 5. Here we go. All right. Each term in the sequence, 13, 9, and 18, is the sum of 3 times the tens digit and 2 times the units digit. So I don't have a fancy method of doing this problem aside from just figuring it out. So the first thing I did was, what are they doing? So I said 3 times 1 is 3, 2 times 3 is 6. I add those together, I get 9. Okay, so I understand what's going on. So at 18, let's go 18. So we have 3 times 1 is 3, 2 times 8 is 16, so I get a total of 19. Okay, so that's bigger than anything I've gotten before. So then let's go with 3 times 1, which is 3, 2 times 9, which is 18, which gives me 21. So now I have a new ones digit. That's kind of interesting. Let's see what happens now. So we go 3 times 2, and 2 times 1. So I get 6 and 2, which gives me 8. So I'm already smaller than my 9 over here. I'm not going to go above 21, am I? All right. Oh, okay. So this is the first really fun problem. So we have a square where the side length is 24. And we have 2 sectors of circles inside that are tangent. And we are trying to figure out this distance right here. So the first thing I'm going to do is I'm going to draw a radius that is connecting both the hemisphere and the quarter of a sphere. And I know that the distance from here to here is 24, because that's the side length of a square, which is the radius of that big circle. I don't know what this radius is, so I'm going to call that r. That's hard to read. So I'll call this r. Well, if this distance from here to here is r, then I know that this distance from here to here is also r. So if I were to make my nice red triangle, I know that this distance is 24. I know that this long distance is going to be, my hypotenuse, is going to be 24 plus r. And I know that is 24. And this distance right here is going to be 24, but I don't want to know the whole distance. I want to know this whole distance minus my radius. So that means this short leg is going to be 24 minus r. And using the Pythagorean theorem, we can figure out what the radius is. So using square binomials, I know that we're going to end up with 24 squared, which is 576, plus 2 times these values. So that's 48r, plus r squared, again 576, and then another 576 minus 48r plus r squared. So now let's cancel out things that appear on both sides. That appears on both sides, so I can get rid of it. I have this 576 that I can cancel out with that 576. So let's add 48r to both sides. Hello.
Are you in the middle of recording?
I am, but having a conversation with you would make this recording more interesting.
Not what I'm telling you can't be recorded.
Okay. Hold on a second. Okay, I'm sorry about that. All right, so we get 96r is equal to 576. So divide by 96, divide by 96, and we get r is equal to 6. Now, we don't want the radius. We want the diameter, and the diameter is 2 times the radius, so 2 times 6 is 12. Right. That's kind of a cool problem. I really like those Pythagorean theorem problems that look undoable until you set it up. All right, 7 and 8. How many distinct unit cubes are there with 2 faces painted red, 2 green, and 2 blue? And rotating a unit cube is going to, it's still the same cube, right? All right, so let's start with the most obvious. I'm going to draw a little flat pattern here. And so if I unravel a cube, it would look like this. And so first, let's go with opposites. So let's call this red. That means the opposite side is red here. Let's go blue. The opposite is blue here, and green and green. So there's 1, because we're in opposites, right? And now it doesn't matter how I rotate opposites, it's always going to be the same thing. So I can't rotate these things about. So the next one is I want to have 2. I'm going to draw the same flat pattern, but I'm going to keep it in order. So G, G, B, B, 6, R, R. And I can rotate this where these fins have a different color. So I could go green, green, red, red, blue, blue, and then the related one here. So I go blue, blue, because I don't have those opposite. And then I can go with green, green, red, red. So there is 4. All right, so now the next one I can do is make sure that all of the colors have adjacent sides. Now this one's a little bit harder to visualize, so I'm going to draw my flat pattern catty corner at a 45-degree angle, and you'll see why. So if I were to draw a cube, and let's say we have blue, red, and green. Well, to make everything adjacent, this would have to be blue. We can put green on the bottom, and we put red over here. And so then, let's take a look at this. All right, so here's red. Here's my back red. So that means my blue is here. A green is right here. For this side, oh crap. So let's call this green, because that's my bottom. My bottom is green. So red, so the one that comes over the top has to be red. So these two will be touching, so like that, and then I have my blue, so they share this edge here. Now I could do the mirror image of this as well, right? So I could do and we have I could just rotate it, right? Go red, green, and blue, and I can never make it the same. So it's going to be the opposite, right? And so at this point, I've done no adjacent sides, 2 adjacent sides, 3 adjacent sides. I can't do any more than that, so I'm at 6 different ways of doing it, which is makes a lot of sense because a unit cube has 6 sides. All right. The coolest of them all. I love these algebra geometry problems. All right, so here's the deal. We have a parabola on a grid. It looks something like this. And we want to know the area of the largest triangle possible. Well, the area of the largest triangle possible is going to be defined by a point at the vertex and the 2 x-intercepts. So I need to find the vertex and the 2 x-intercepts, knowing that this is at a height of 0, so really I need my y value here. And so let's go about figuring that out. So we have negative, I'm just going to rewrite the quadratic 1/2 squared plus 3. So let's multiply this out. I'm going to have a hard time factoring this whole expression once I expand this and add the 3. So that means I'm going to have to use the quadratic formula to get my x-intercepts. So that's the first thing I'm going to do. So here we go. So this squared, I'm going to unleash this as a square binomial. So it's going to be x squared minus 1x, because 1/2 plus 1/2 is 1, plus 1/4, and that's all plus 3. I'm going to distribute that negative, so I have negative x squared plus x minus 1/4 plus 3. Okay, hold on a second. Yeah, I know this, right? Okay, so then I'm going to combine this, and so I get negative x squared plus x plus 11/4. So I'm going to keep it as a fraction because that's easier to deal with than a decimal. All right, so that means my a value is going to be the coefficient for my quadratic term, which is -1. My b value is going to be the coefficient of my linear term, which is +1, and my c value is 11/4. All right, so to find the line of symmetry, we know the line of symmetry is going to be equal to -b/2a. All right, great. So that means we have -1/2 times -1. And so that gives me +1/2. So this is at x equals 1/2. So I need to now find my y value. So 1/2, let's plug that into here. 1/2 minus 1/2 is 0, which gives me my maximum here. So this is actually called vertex form. And so where the opposite of this term is going to be the x value of the line of symmetry, and this is going to be the y value of the line of symmetry. I would have gone a little faster if I just said that up front, but whatever, we're doing good. So we know that the height of my triangle is going to be 3. So now I need to find my base. And so using this here, we're going to use the quadratic formula, which is -b plus or minus the square root of b squared minus 4ac all over 2a. I should have done that in another color, but I didn't. I'm not going to subject you to my singing a second time. All right, so we have -b, which is 1, plus or minus the square root of b squared, so that's 1 squared, 1 squared is 1, minus 4 times my a value, which is -1, times my c value, which is 11/4. I'm going to get rid of my fraction pretty quick. Isn't that nice? All over 2 times -1. All right. So here we go. This 4 cancels with that 4, so I end up with +11. So I get -1 plus or minus the square root of 1 plus 11, which is 12, all over -2. So at this point, I'm going to, well, I should probably rationalize that. So the square root of 12 is going to be broken to the square root of 4 times the square root of 3. The square root of 4 is 2, so it's 2√3. Ah! All right, so that's 2√3. So I'm going to break this apart. So I have -1 over 2 plus or minus, oh, well, these will cancel, square root of 3, which means I have 1 at negative divided by negative is positive. So I have 1 at 1/2 minus square root of 3, and this one's at 1/2 plus square root of 3. So to find the distance between the two, I'm going to go 1/2 plus square root of 3 minus 1/2 minus square root of 3. So 1/2 minus 1/2 cancels out, so square root of 3 minus the square root of 3 as well as subtracting negative, same as adding positive, so it's 2 root 3. So the base is 2 root 3. Great. So then 3 times 2 root 3 all over 2, because the area of a triangle is half. Right. Base times height. The 2's cancel out, so I get 3 root 3. I'll write that nicer.